Hello, and welcome back to part 2 of the Cubix tutorial. Last time, we learned about modular data types, ways of creating a single while loop node that can be included in multiple languages. And so the ability to create these various language fragments and then put them together into a bigger language, it's kind of like having a giant pile of generic modular Legos. But somehow from that, you needed to construct Java. And we don't want to construct a skyscraper out of Legos. Rather, it would be like this guy who is surgically modifying an existing definition to make small changes. And that's how we want to do. We want to be able to take existing language definitions for these languages and then change small pieces of them to make them modular. So let's think about trying to replace the variable declaration node in all these languages with a single generic variable declaration node. And so if we look at the variable declarations in these languages and think for a bit, come up with this definition. This is actually a bit simplified, but it's this definition. You can say a variable declaration has the variable, the name you're declaring, something you're an optional thing you're initializing it to, and some attributes. So read this as int x equals 0, for example. But these attributes, and really all of these pieces, can be different things, different languages, even though we're trying to create a single generic idea of a variable declaration. So for Java, these attributes are just a Java type, whereas in C, it's stuff like const volatile register instar. It's something pretty complicated. And our big idea is sort injections. We're going to choose what things are subsorts of this mysterious variable declaration attribute sort. So in Java, if we include this variable declaration node and we have a sort injection from Java type to variable declaration attributes, the sort injection is just an injective function between sorts. It's a subsorting relation. So for the Java definition, we make Java type be a subsort of variable declaration attributes. And now you can use Java int and string where this attributes goes. Whereas in C, you have this more complicated thing that covers things like const volatile register instar. You make that be a subsort of variable declaration attributes. And now you include these in your language definition. And now you have this generic variable declaration node acting like these very complicated C-specific variable declarations. So that's pretty cool. And the way that you add these sort injections to a language is actually, so sort injection is like an edge, saying there can be an edge in my AST from variable declaration to Java type or const volatile register instar. So the way that you add these possible edges to your language definition is actually by turning the edges into a node. So you say this edge from variable declaration to Java type is going to be a node of sort variable declaration attributes, which has one child to sort Java type, and that is a sort injection node. And so this is how Cubix represents ASTs as a mixture of language-specific and generic parts. And the glue between them is these sort injection nodes. They control where the generic nodes can go in the larger tree. And it's incremental in that we can have 90% of the language definition, even 95%, 99%, be the same as the original, what we get from an existing library. We need to do a transformation that only deals with some of these nodes, replace a few of those with generic things, and we're good to go, and we can change the definition later. And so that's how we're able to get support for so many languages so quickly. So I want to show you what constructing an incremental parametric syntax looks like for real. I'm going to show you the one for Lua. We use Lua a lot for examples because it's the smallest of the languages. That's actually part of why we did it. semantically, it's pretty complicated. It's very dynamic, but syntactically, it's probably the simplest, well-used industrial language. It's used for a lot of embedded systems, deep learning, game scripting, and stuff. So the starting point is actually, where'd it go? The starting point is actually from this third-party language Lua library. And this is written by some people I've never met, and that doesn't stop us. So here's the original AST, and here's the Cubix AST. So note when looking at the Cubix docs, always hit collapse all instances. So you can actually find a close correspondence between what's here and what's here. So let's look for table field ID. Whoops. Oops, sorry, just table field, not table field ID. So we can find table fields in here. And we see that a table field can either be an X field, a named field, or just a field, as it is in the original Lua ASD. Although because of the GADTs and the fancy modularity stuff, it's a bit harder to read here, but they are isomorphic. And we've replaced pieces of the Lua AST with generic nodes. So let's see how that looks. So, okay, so let's talk about this one, for instance. So in Lua, so in Lua, if you have a function call, there's actually a couple kinds of function call. So you can have a normal function call, which looks like it does in any other language, but you can also give a table as a way of doing keyword arguments. So there are different kinds of parameters in Lua. And so this is not an ordinary parameter. It's not a positional parameter. It's when you have something like this, no parentheses can be the only parameter. So this does not fit well into, well, it does fit well, we may actually, but it is not modeled with a generic kind of function parameter. So we have some various special Lua nodes for that purpose, which can be mixed in with generic argument lists. So we write some custom data types for this, generate some type classes for them, and we have to generate some sort injections. So we're going to say that any expression can be a normal positional argument. So there's a sort injection between them. Similarly, a Lua statement can be used inside of a block. So a Lua statement is a generic or parametric block item. A generic identifier can be used where a Lua name is expected. So there are a bunch of these. And then the fun part, we literally, with code generation, with template Haskell, are taking a list of all the node types in Lua and just subtracting some things, and then adding in our new generic nodes and our new glue nodes. So this right here is the core of incremental parametric syntax. Take an existing language definition, subtract out some of the old nodes, out with the old nodes, and in with the new. And then the rest of this is just some various operations. Sort injections solve other problems as well. And a sort injection isn't about the node, it's about the subsequent relationship. And that can be witnessed by a bunch of intermediate nodes as well. So I want to write a transformation that knows about generic assignments, and it knows about generic blocks and the stuff that goes in blocks, which we call block items. Can you put an assignment in a block in C? Of course you can, because an assignment is an expression, which is a statement, which is a C block statement. So there's a sort injection between assignments and blocks items. And in JavaScript, assignments are also block items, but there is a different chain of intermediate nodes. In fact, in the third-party definition we're using, for some reason, they have assignments both as statements and as expressions. But this all gets abstracted to assign is a subsort of block items. There's a sort injection from assignments to block items. And with that, you're actually able to write generic transformations that only work with these generic nodes, even if there are a bunch of language-specific things right in between them. And with that, move on to exercise 3. And then exercise 4 is self-guided. But there's a lot of stuff written on the exercise itself to help you learn some more advanced things there. And that concludes the lecture. So come use Cubix. I want you to write multi-language tools. We're going to support you very hard if you do. All the information's at our website. And any help, go to our mailing list. So thank you, and I hope to see some multi-language tools.